Welcome back to Scaling Theory. My guest today is Yann LeCun, a pioneering French-American computer scientist known for his groundbreaking work in machine learning, computer vision, and neural networks. Yann is the Silver Professor at the Courant Institute of Mathematical Sciences at New York University and serves as the Vice President and Chief AI Scientist at Meta. Yann is one of the world's most influential computer scientists. He has accumulated over 350,000 citations on Google Scholar. He is one of the founding figures in the field of deep learning thanks to his contribution to convolutional neural networks and backpropagation algorithms. And he is one of the most vocal proponents of open source AI. In recognition of his significant contributions to artificial intelligence, he was awarded the Turing Award in 2018, often referred to as the Nobel Prize of Computing. Our conversation is structured in three distinct parts. We begin by discussing the overreaching dynamics in the AI space, then narrow our focus to the firm level, and finally, we conclude with an exploration of the challenges that lie ahead of us. By the end of the discussion, you will learn whether open source has a chance to make it in AI, the key factors for scaling an AI foundation model, the role ecosystems play in market dynamics, Meta's long-term strategy in the space, how concentration among chip manufacturers impacts AI companies, the current effect of the European AI Act on AI companies, what Yann would like to see regulators doing, and more. I hope you enjoyed the conversation. Regarding part one, so again, looking at the overall macro dynamics in the space, I want mostly to talk about the intersection of markets and technology today, but let's start with some unconventional truth about AI. And I guess the question would be, what do you wish more people will agree with you on?
The world hasn't seen everything yet with AI. So we're still very far from reaching human-level AI, despite the success of recent architectures. They're still extremely limited. And we're not going to reach, human-level AI for quite a while. There's still a lot of work to do, very basic science. It's not just a question of technology. So that's the first thing. The second thing I'd like people to know is not to fear AI, basically to see it as a tool. It's a tool. It will remain a tool. Even if AI systems become smarter than most humans or even all humans, they will still be a tool. We'll still be in control of them. They will assist us in our daily lives, and they will amplify human intelligence, really. So how best to do this is, of course, as much of a societal question as a technical question. But, history and institutions are there to make the best of technological advances.
And we have very good example looking at the political landscape of people in charge of countries, organizations who are not necessarily the smartest people in the room, right?
Yeah,
so
right.
it shows that, being smart is good, but it's not because you're smarter than someone then you will dominate. And
yeah, that's right. Intelligence is not correlated with a desire for dominance, certainly. Even within the human species, as you just mentioned, it's not necessarily the smartest among us who want to dominate others. Now, in human species, there are several ways to attain status. One of them is, domination, submission, but a more reasonable one is actually through prestige. You have influence because people trust you, so you attain status because of that. So this may not be the case in other species, like say baboons or chimpanzees or others, where dominance perhaps is the main thing, but it's mostly obtained through physical force, not through intelligence. So I work with people who are smarter than me. It's great. It's wonderful. If we all had intelligent assistant working for us that was smarter than us, it would be great. It would be, everybody would be better for it.
Yeah, certainly. All right. So, taking a foot high, how do you see the market structure of foundation models in, let's say, 5 years from now? So, do you think we will be in a position where 3 or 10 or 30 AI models will capture, let's say, 80% of the market? And I'm asking the question because Hugging Face just announced that they passed 1 million models. But obviously, a few of those models are taking the leads, including those developed by Meta, OpenAI, Microsoft, Google, Mistral, Cohere, etc. So, how do you see that evolving in the near future?
Well, I think there's a spectrum of models, and it depends on where we place ourselves in that spectrum. So this is the spectrum of closed versus open, proprietary versus free, essentially, right? At one end of the spectrum, you have AI systems that are completely proprietary and closed, cannot be modified, or can be modified only but with difficulty and only in limited ways. So this is really the approach that OpenAI and Google have taken, and Anthropic and a few others. At the other end of the spectrum, you have models that are basically completely free and open source, and anybody can do whatever they want with them. And then somewhere in the middle, you have things that are, partially open, where people can do most of the things you can do if it's completely open and free, but not necessarily everything. And the models that Meta has produced are pretty far on the spectrum of open, but not completely open. There are some restrictions of what you can do with those models for safety reasons and legal liability reasons and things of that type. So where is the market? Where's the market today, right? So you have a number of open source models which are derived from a relatively small number of base models produced by Meta or by Mistral or by a number of other outfits. And then you have a bunch of proprietary models by Google, Anthropic, OpenAI, and several others. And my vision of the future is that almost the entire ecosystem of models that people will actually use will be based on open source models. The reason being that if you want open source models, if you want a model that caters to your language, your culture, your value system, your political leaning, your centers of interest, it has to be essentially a specialized model that is derived from a bigger foundation model. And it's very difficult for a single company to do this for the entire world. It's very difficult for a single company to build a system that speaks all, few thousands of languages in the world. Whereas it's quite possible for any group or government or company or startup or interest group or nonprofit to actually take an open source model and then fine tune it for their own purpose or their own constituency or their own customers or whatever it is. So in the end, that's the way it's going to be. The most models that would be in the hands of people would be based on open source base models, foundation models. And of course, they'll probably be based around not just the best ones, but the ones that have the best combination of, or the best trade-off between performance and cost of running. Because, big models are really expensive to run, even if they are free in terms of licensing. You still need big computers to run them. And so there is a drive towards using smaller models, but then you lose a bit of performance. So, open source model gives you that ability, gives the ability for the research and development community to really kind of make progress on the efficiency of those models. And we see this every day today on the AI market, where people come up with new ideas to kind of, run these models faster on kind of smaller hardware, in your smartphone or your laptop or whatever, which really wasn't possible just a year ago.
Yeah, and so you actually released Llama 3 just a couple of days ago. And over the weekend, Hugging Face once again announced that, if I'm not mistaken, over 1,000 variations of the model have been already published. Now, people are sometimes under the impression that because it's more leaning toward open source, that people can use those foundation models for any purposes. But indeed, if you look at Meta's licenses and other companies' licenses, usually derivative works is limited in a sense that you cannot use it for child pornography, you cannot use it to promote terrorism, and so on and so forth. So, so something you've mentioned already is that looking at the market structure is interesting, but there is a great divide between closed source and open source, and of course, it's on the spectrum. Now, what's interesting is that big tech companies, to take a label that we've been using a lot in the last 15 years, are positioning themselves very differently when it comes to AI, with Meta being more on the open source side than many others. Now, the question is, how confident are you, and how confident, I guess, AI developers can be that Meta will stay on the open source side and won't eventually move to the more closed source side of the spectrum? I guess one way of answering the question would be, if you were to leave the company, would open source remain the norm? And that's a way for me to ask if open source is fragile, meaning that it depends on small changes such as one person leaving the company, or more robust.
It's more robust. So there's a mistake not to make. It is not the case that that Meta has a open source policy because I'm here, but it is the case that I'm here because Meta has an open source policy. So this was one of my first questions when I was being recruited by Mark Zuckerberg and Mark Schupfer, which was, we're going to do research in AI. This is going to require collaborations from everyone, including the academic world, perhaps some of our competitors as well. So we need to do open research, and this has the fact that the AI research community has freely exchanged ideas and papers and code is the reason why AI has progressed so fast in the last decade. And certainly, Meta has played a huge role in this, in particular with the release of PyTorch, which is the tool that is almost universally used by the entire research and development community in AI, except for a few people at Google because they have their own tools. But that's really kind of become a common platform. Now, this is really in the DNA of Meta. Open sourcing platform software has been done by the company, since before I joined. Mark Schupfer, the previous CTO, came from the open source world. He was chief engineer at Mozilla before coming to Meta. So they really get it. The leadership of the company really gets why this is a good thing. Now, that said, open source needs to be done responsibly, and the one big reason why Meta might change its mind is because of legal reasons or new laws or liability rules or things of that type. That may have a chilling effect. If you have a regulation that says that that sort of propagates liability all the way up the chain if someone does something bad with an AI system in certain countries, then probably the logical thing for a company would be to not do open source anymore. And so that will really depend on the regulatory landscape. There's already rules in the US and in the EU that says if you train a model with more than 10 to the 26 flops or 20 to the 25 flops in the EU, you need to get a license and basically disclose a lot of what you're doing. It's not an issue for companies like Meta that are big enough to be compliant, but it might be an issue for smaller companies. So it might have, depending on how it's applied, it could have a chilling effect on the open source ecosystem down the line. The idea that open source is good, there's several reasons, and I've said this multiple times, and Mark Zuckerberg has as well. The first one is that open systems tend to be more secure and safer because there are more eyeballs looking at them and finding problems with them, etc. So they get fixed faster. They tend to progress faster because, again, more people contributing to it, so the technology progresses faster. And there is a very strong market drive towards open source common platform. Whenever something is a common platform, there is a huge incentive for the industry to adopt open source platforms. Because, if you build an entire ecosystem on top of a proprietary system, it could be that the owner of that system, stops supporting it or changes the design of the API in ways that are not convenient and things like this. It's just too dangerous. And so what you've seen is an evolution fairly quickly on the internet. For example, the entire software stack of the internet is all open source. Not just the network communication stack, but also operating systems. The internet runs on Linux. Web servers, the internet runs on Apache. Server-side frameworks, databases and scripting languages and stuff like that. And even the core of every web browser is open source. The web browser themselves aren't, but the core around which the engines around which they're built is open source. A similar thing occurred, strangely enough, in cell phone communication. The entire software stack of cell phone towers is open source as well. And it's because it's infrastructure. So if we imagine a future where every one of our interactions are mediated by AI systems, it really becomes an infrastructure piece of software, and you can't afford it to be closed source. It's just too dangerous for the industry.
Yeah, and you mentioned the idea of changing design if indeed it is closed source and you have that power coming from antitrust. If you take a step back and look at all the past cases, or pretty much all of them, you see that at the core, it's a company changing indeed the design of an ecosystem because they have the power to do so in a way to capture value for them and not to benefit the greatest number.
Yeah.
Moving on now to part 2 of the conversation, looking at the micro dynamic. So what's necessary at the level of a company in order to make it in the space. What would you say is the most important thing to scale an AI foundation model? I'm thinking big data, unique data, talents, compute, access to VCs, venture capitals. Of course, companies want all of that. But what do you think matters the most in terms of defining dynamics?
Yeah, the short answer is all of the above, unfortunately. I'd say talent first, but talent not necessarily in-house. So you can partner with, there's a lot of smaller companies that are being formed that basically are in the business of fine-tuning base models for particular vertical applications. And you might, have a contract with one of those for your own application. So, for example, you are an enterprise and you want some sort of internal information system, an AI assistant that knows all of your internal documents so that any employee can ask, any question. You could do this in-house, or you could, hire a small company to fine-tune a base model for you. There's probably no point training your base model anymore because the open source models or even the proprietary ones are good enough, really expensive, require a lot of resources, investment, a lot of OpEx for fine-tuning those systems so that they answer proper questions that are trained on different languages, etc. So that's become kind of a big operation, which I think only a few players can really play in at a high level. But the business of customizing a base model for a particular application, I think, is a good one. Okay, so talents first. Second one is if you want to specialize a system, it means you either have access to data or you need access to data for that specialized system, whether it's healthcare, whether it's internal information system, business intelligence, whatever you want, or whether it's just a system that speaks particular languages in a particular region of the world, right? If you are in India, there are 22 official languages in India and a few hundred dialects. There is an effort in India to fine-tune Llama 2 and probably now Llama 3 so that it speaks all 22 official languages and soon will speak all most languages and dialects. Similar issue in Africa. Former colleague of mine has a company that uses LLM to provide medical information, basically access to a virtual doctor if you want, or advice for like first medical contact. It's very hard to have a appointment with a human doctor in Senegal, for example. There's a small number of them, when you compare to the population, and they're all in big cities. So an AI system can play an important role, but it has to speak, 5 local languages, in addition to French, like Wolof and a bunch of others. So that's enabled by open source. So I see a very flourishing ecosystem there. So you need data for that. Some of which may be proprietary, some of which may be open. I think it would be in the interest of a lot of regions and cultural groups or countries to actually provide free data, open data to fine-tune systems, because then those systems will speak the language. And if they put the condition that the resulting system needs to be open source, then it's not going to be ripped off by commercial entities, closed source entities. Yeah. I think there would be a strong incentive for open sourcing models, actually. And then there is compute. And, compute is, prices are coming down, and also the techniques are improving so that it's not nearly as expensive now to fine-tune a system as it used to be. You don't need like a huge amount of GPUs and stuff. And more cloud providers provide computing resources that are easy to use and not too expensive. So I think that's making fast progress. Basically, it's not Moore's law anymore, but it's a similar effect where the efficiency of computing infrastructure is really improving quickly.
And coming back to data for just a second, how important is unique data? So the data that Meta has access to in the training of your LLMs and Llama 3?
It's not important. So it's not used. There's no specific, there's no data specific to Facebook or Meta that is used for pre-training a system. It's all public data, essentially.
Okay.
But then what most companies now spend a lot of resources and money on and time is fine-tuning. So you train a base model, but it's not very good at answering questions. So now you have to have human moderators or trainers or teachers, perhaps you could call them that way, basically interacting with the system, have the system produce multiple answers for a particular question, and then rating the questions or just typing a correct answer to a particular question to fine-tune the system for particular things. Some of that can be automated for things like code generation or teaching a system to do arithmetics properly or things like that, or teaching it certain scripts that need to be done. So a lot of resources are spent in the second phase of training, and that's proprietary data at the moment. I think it would be very useful to form consortia eventually that would essentially produce public data for this kind of fine-tuning of base models, so that they speak every language in the world and cater to all the cultures and things like that. So that we don't have systems whose biases are merely reflect the bias in the data that is widely available on the internet, which is mostly English.
Yeah, indeed. And so now coming back to compute, do you think that small scale foundation models, or at least smaller, I like to call them, good enough foundation models, because it's not as if because a test will reveal that one foundation model is slightly better that everybody would then suddenly move to those, right? So do you think those good enough foundation models will eventually compete with frontier models, and how much competitive pressure, I guess, do they put on Meta today?
I think you're always going to have frontier models that require tens of millions or hundreds of millions to train very large expertise because they might use innovative techniques and architectures and enormous amounts of compute, clusters with tens of thousands of GPUs, and access to data sets that may not be accessible to everyone. So you're always going to have frontier models of this type. Then the question is, most frontier models are going to come in multiple sizes so that they cater to like different segments of the market.
Yeah.
There's complex problems that probably can only be solved with big models, but big models are expensive to run, so economically it may not make sense. So Meta has released Llama 3. There's an 8 billion parameter version, which by yesterday's standard is very small, but actually works really well for that size. And then another model is 70 billion parameters, and there is an upcoming one which is still training, so we haven't released it yet, with 400 billion.
Yeah.
So that, and there's going to be probably other on the spectrum as well. So each of those can play an important role depending on the application.
Yeah. And so now if you look at the dynamics, of course, the quality of a model is essential, because obviously if you were to use it and the answers to your prompt is always crap, then you will stop using it.
Yeah.
But it seems to me it's not the end of the story, because if you see that an ecosystem is being built on top of a foundation model, it may be compelling for developers to move to this one in order to benefit from compatibility. And then suddenly you may see that it will create increasing returns, and then more people will be attracted to it, and the company will generate more revenue, and therefore will be able to pay to get access to better data, and so on and so forth.
Yeah.
And that leads me to two sub questions, I guess. The first one is whether you think that small open source AI models can realistically survive if they do not have this opportunity to create such an ecosystem, which I guess is easier for Meta than it might be for a small startup created in 2024.
Yeah, that's a good question. I mean, I think what's important is sort of have kind of a figure of merit. So there's a number of benchmarks now. You can take them with a grain of salt or not, but that kind of measure the performance. Some of which use human feedback. So they, it's kind of like chess players or tennis players, right? You play one system against the other, and you use human judges essentially to judge which one was best for that particular question, and then you count how many times one model wins, and you can rate the models relative to each other this way. And what's important in the end is sort of a two-dimensional diagram where a model is at a particular location where the x-axis could be performance and the y-axis could be expense of running the model, or on the other hand, not the expense, but the speed at which the model can be run, which is the inverse of the expense, if you want. And what you want is a model to be kind of to the top right corner. The closer it is to the top right corner, the better performance you have and the better speed you have. And so a family of model will be sort of more or less on a line, on a diagonal line, and you want them to be as close to the top right corner as possible. And what you see is Llama 3 right now is pretty close to being top, essentially, on the line. There are models that are better, but they are way more expensive. There are models that are cheaper, but they're way worse, and etc. And models that just don't have the same trade-off, right? So this is what I think people will monitor, the sort of the price performance, essentially, figure of merit. But it's going to be hard for small outfits to kind of convince the entire community that their model is going to be able to keep up if they don't have hundreds of millions of capital to spend on compute, or if they don't have billions of revenue that they can use to train those models, which they need to spend anyway for their own internal purpose, which is the case for Meta, obviously.
Yeah. And so, and this will be sub question 2, how likely do you think it is that in a not so long distant future, foundation models will be actually commoditized? And I'm asking because I could see how this could also be a good business strategy for Meta, because the company can monetize the application layer,
Yeah.
and potentially, hurt competitors that way if they plan on making money at the foundation model layer. So again, is it possible that you think they'll be fully commoditized in the future, or do you think, there's always be a possibility to have some commercial applications?
Well, so I think the space is going to change significantly over the next several years, in the sense that future AI systems a few years from now will be different from the current one. Very different. They're going to have, the ability to understand the physical world, to have persistent memory, to be able to reason and plan in ways that current systems really aren't. And so there's going to be new players in that game, and they might be different from the current ones, right?
Mm,
A good guess is that the ones that will be players there are the ones that can invest in research, long-term research, not just
yeah,
fine-tuning current systems, but how do we change the paradigm, which is basically what I personally work on. Okay, the next generation AI systems. To people like me, LLMs are the past. Essentially, they're kind of boring now. Um, of course, they're very useful, and there is a whole industry that should be built around them. I'm not saying the opposite, but if you're interested in the future, there's kind of a lot more that will happen in the future, and it may completely change, what we perceive. I mean, it's entirely possible, for example, that system will become a lot smarter with a lot less data. Um,
mm,
Humans are not exposed to nearly as much text data as current AI systems, yet we're still a lot smarter than those systems, right?
yeah,
So a little exercise that I've been doing in the last year or so is to say a typical LLM today is trained on the order of 10 trillion tokens. Llama 3 is trained on 15 million tokens, 15 trillion tokens. I'm sorry, right? So that's 1.5 with 12 zeros behind, right? So it's like a 1 with 13 zeros, or a 2 with 13 zeros. And the number of bytes is that corresponds to is just twice that, right? So a 2 or a 4 with 13 zeros behind it. That's the amount of data in bytes, because a token can be represented in 2 bytes typically.
yeah,
Now, that seems like an enormous amount of data, because it would take a human on the order of 100,000 years to read through that material, right? So it's enormous, right? And those systems have accumulate a lot of knowledge, like factual knowledge, because they've been trained on that much data. But they're not very good at really sort of being smart about it, like inventing new things and new techniques, and reasoning and planning and inference. And they certainly don't know anything about, or not much about, the physical world yet. Now you compare this with what a child sees, and a 4-year-old child has been awake a total of 16,000 hours. The amount of information that has reached it, his or her visual cortex in those 16,000 hours is on the order of 20 megabytes per second. So multiply this by 16,000 hours, that's about 10 to the 15 bytes. That's 2 orders of magnitude larger than the amount of data that the biggest LLMs have been trained on. And so what that tells you is that there is a lot more information in sensory input, particularly through vision, but also through touch for humans,
mm,
and audio, than there is than there is in text. Text is really sort of a distilled uh, source of knowledge, built on a foundation of basic knowledge that results from our human experience, of the physical world. And current LLMs don't have this experience. Until they have it, they're not going to reach human level intelligence.
yeah,
And what that tells you is that if we were able to train a system to learn how the physical world works, the way babies learn how the world works in the first few months of life, maybe we wouldn't need that much data in the end to get them to the same level of intelligence as humans.
yeah. And I guess everyone who actually raised a child would know that your kid may do something, although you never explained how to do it, and
Yeah.
it feels like magical, but it's probably because the kid have seen you do it or heard about it, or indeed maybe it's one of the other senses. Okay, let's move on now to part 3 of the conversation, discussing the challenges. Um, there is one that we kind of touched upon already, and that's the one of the concentration we see at the moment at the infrastructure layer. So, in terms of compute, chips, and so on and so forth. A lot of players are getting into it. So, it's not as if the space was not dynamic. But in 2024, are you struggling to get access to chips? And are you worried that you won't get enough compute resources in the next coming years?
Well, you always need more compute, but then, past a certain scale, there are kind of other factors that matter other than supply of chips or systems. There is like supply of energy, for example. Um,
Yeah.
so and then the practicality of having tens of thousands of computers working together. Like what algorithms are you going to use to parallelize over tens of thousands of computers or nodes in a cluster? So there's a number of different problems, but clearly in 2023, a big bottleneck was the supply of high performance chips that are capable of the type of numerical performance that we need for training deep learning systems, right?
Yeah.
And there is a quasi monopoly by NVIDIA, um, not just because their chips are of very high performance, but because their chips are designed for two things simultaneously: one for numerical computation and AI, and the other one for gamers and graphic rendering. And so they can
Yeah.
amortize the investments they do in the design over a high margin market that is growing and a very, very large lower margin market for gamers. But
Yeah.
it's the same chips, really. It's the same design. So they can spread the cost
Yeah.
over that. Um, the other advantage that they have is um, a very good software stack on which they've been working for 20 years or 15 years, initially for scientific computation, and in the last dozen years or so for deep learning neural nets. So that gives them an edge. And then a lot of other players, of course, have meant to enter the market and so far have been largely unsuccessful. This might change over the next few years.
Yeah.
Um, so that includes Intel, which has made many attempts through internal projects and acquisitions of startups, and not much has come out of it until fairly recently. That includes, of course, AMD, which was a bit late in sort of investing in this kind of stuff, and because of their financial difficulties, I guess, early on. They're doing better now, but they need to catch up with the software stack. Um, and then a number of kind of smaller players and startups that kind of make different choices. So another player has been Google with the TPU, and then Meta has started developing its own chips, and they are mostly used for at the moment for inference, for ranking feed on Instagram and Facebook, but eventually also for inference of LLMs and other types of neural nets for content moderation, for example, and as well as for training eventually. And then there is a lot of smaller players. A company that a lot of people are talking about at the moment is Grok, GROQ.
Mm.
They build inference chips that do a really good job for running LLMs relatively cheaply. So this may change a lot in the near future, and there's a huge incentive to produce chips that are very economical in terms of energy consumption and things like that.
Now, looking at a non-technical challenge and moving on to the legal field, as a engineer and a chief engineer at Meta and someone who's been involved in the space for quite some time, what role would you like the law to play in shaping AI models, if any?
Well, I think the first thing is like it's like medicine, right? It's do no harm. So essentially, uh, yeah, making sure that regulations do not impede research and development, and certainly do not impede open research and development, because this is really what is necessary for a good ecosystem to emerge. Um, so that would be the first thing. The second thing is, of course, regulation at the product level to ensure the safety of the products that are deployed. But most of those regulations already exist. They are in place for things like transportation and healthcare and things like that, right? So whether those systems are AI powered or not, to some extent, is irrelevant. So you don't necessarily need regulation that is specific to AI. Of course, AI enables certain functions that would otherwise be impossible, like, for example, massive surveillance in public spaces, face recognition in public places, which most liberal uh, democracies would say is uh, not appropriate. So, having regulations that limit the uh, ability of various entities, including governments, to spy on people, I think is a good idea. And there's some of those provisions in the AI Act for the EU, which I think are good. Um, protecting private data and things like that are good things. But like, there's no reason to regulate research and development. There is, a myth, which is that uh, super powerful frontier models are intrinsically dangerous. That the mere fact of bringing them to existence might be a threat for humanity or human welfare. And that's just not true. It's not going to be true for quite a long time. And so the kind of regulation that was established in the US and the EU uh, based on that fear, I think are misguided. They run the risk of, killing an ecosystem early for no reason at all, based on the myth of existential risk that really doesn't exist.
And you've mentioned indeed the fact that all kinds of laws already apply to AI, right? So tort, criminal law, contracts, and so on and so forth. We hear sometimes that AI is not regulated, and that is why we need to move and impose regulations. But it's not because you use AI then you can suddenly escape the law.
Of course.
That reminds me of the AI Act. Expert systems were originally in the definition of AI, and I thought to myself, well, they've been around for quite some time, and I failed to see the kind of problem they will pose that will necessitate that we do integrate them into AI.
Right.
Now, the new definition of AI in the AI Act is closer to the OECD, so it's more machine learning based. But talking about the AI Act, is it affecting your daily work at Meta? And to be clear, this is not yet enforceable, but it will
Yeah.
be in the coming month. Is it something you've been discussing with lawyers? Are you in touch with the legal team at Meta? How does it work internally?
I mean, certainly at some point it's going to affect what we can do and cannot do. As I said, Meta is a large company that's already, regulated in several ways. So, unless the laws are incredibly restrictive, the compliance is not going to be an issue for a large company like Meta. It's going to be more of a problem for smaller companies. It may be maybe much more difficult for them. Like if you're a small company, and let's say you're going to download Llama 3 and you decide to fine tune it for some application, and somehow you fall under one of those rules that regulate R&D. Are you going to take the risk of releasing your model in open source because you might be liable for something that you really don't have the financial strength to defend against? So this may have a chilling effect, but depending on how those rules are applied, this may or may not have a big effect.
Yeah, to some degree, we've seen that with GDPR already, right? We know that the costs are proportionally much higher for small companies than they are for big companies. And in fact, some empirical research have been published quite recently showing that because of GDPR, companies in the EU are actually storing 20% less data than what they do outside of the EU, and so they are less data intensive. Okay, let me ask now a final question. So, talking about the AI Act and the fact that it may indeed create a sort of regulatory capture in a sense, benefiting the big companies that can afford. One article that I think illustrates that quite nicely is Article 11, that imposes on companies to release the technical documentation and explain how their AI system actually complies with EU fundamental rights. And it seems to me this is typically the kind of stuff that a big company can afford and a small company will struggle to actually produce. Um, and I could see how this should be the main objective of all competition agencies, which would be to list all regulations that exist already and that may hinder small companies, open source, if it's more distributed, decentralized. Do you see already evidence of regulatory capture in AI all over the world?
No, I see attempts at lobbying, governments around the world to establish rules of this type, very often based on this kind of myth of existential risk, to kind of convince them to establish some regulations. And some of those lobbying are, are motivated by the desire to do regulatory capture by companies that think they are ahead.
Yeah.
Now, there is some other lobbying efforts from people who are really worried about existential risk. In my opinion, they're completely wrong, but they have well-funded campaigns, lobbying campaigns among others, and various others that convince various people in the government to work towards more regulation because they're afraid of existential risk. And of course, if the public somehow believes that there is existential risk, the politicians have to respond to this. They have to say, of course, we're here to protect you. We're going to do something about this, right?
Yeah.
But then this is all a myth. So it's. We've seen this before with other technologies. A good example is nuclear power, which two very similar countries, France and Germany, made completely different choices in the 70s. France, investing massively in nuclear, and Germany kind of progressively phasing out. And now it turns out that the choice of nuclear power was a good one because it's low emission. So if you're worried about climate change, having a lot of nuclear power is actually a very good thing. So having sort of irrational fears about technology sometimes leads you to make the wrong choice, or for the wrong reasons.
Yeah, there is a great book by a historian of technology from the MIT. He explained that new technologies are always welcomed in three stages. First, the companies or people in position of power ignore the new technology. Then they engage in rational arguments explaining that it cannot scale, it cannot work. And then if they see that the technology is progressing, they engage in a name calling, right? So they would say it's dangerous, killing, and so on and so forth. Do you have a final message? Something that I failed to ask you that would have led to a great answer on your part?
um, okay, I see a future where a lot of every one of us, almost every one of us, will be interacting with AI assistants that will be personalized. They will be our assistant, perhaps our digital best friend. Those systems might end up being smarter than us, but they will assist us. So they will amplify our own intelligence. We'll be in control of them. We'll set objectives and goals for them. And they may be better than we are at executing those objectives. And it would be as if everyone had a staff of smart people working for them, but they would be their boss. Okay, so that's the future that we should imagine and we should build. There are other futures that are not nearly as nice, and we just should not build them. And the effect on humanity might be enormous, of the same importance as the invention of the printing press in the 15th century, where people became smarter because of access to knowledge and books and literacy. It basically enabled the Enlightenment and emergence of science and rationalism and democracy and philosophy and things like this, right? So without which the American and French revolutions would not have happened. So amplifying people's intelligence has some effects on society that are mostly beneficial. There's always dangers, risks, but overall it has to be positive. We have to work for it to be positive. So perhaps we'll witness a new renaissance.
Hopefully. Both of us, I see, have a bias towards increasing or scaling the overall level of intelligence all over the world. So thank you very much for your work, for your contribution, and to everyone out there. Take care of yourself, and if you can, someone else too. Bye-bye.
Bye-bye. Thank you.